whispering storyteller. I do hope you are well tonight and somewhere nice and relaxed with a nice cushion and nothing to disturb you. Now tonight we're going to talk all about a fascinating subject. This is something I have been in awe of as far as I can remember, and it is the Voyager 1 and 2 space probes. Now, let's have a look. Now, the Voyager space probes will outlast our sun as they travel through interstellar space, and here's a few key facts and figures that we've learned over the last 40 years. So since 1977 when they were launched, Voyager 1 and Voyager 2 have been travelling through our solar system, unveiling the mysteries of the outer planets and discovering new moons. And can you believe that we're still receiving data from the Voyager probes as they make their epic journey through interstellar space? But what will it teach us, and how long will they continue to communicate with us? Well, let's have a look at a few things, So, first of all, why was Voyager launched? Before Voyager, our knowledge of the giants, which was Jupiter and planets Saturn and Uranus and Neptune, were minimal. Having only visited Jupiter twice and Saturn only once by human probes, there were many uncertainties regarding the four planets, including their compositions, moons, magnetic fields, and potential ring systems, which the Voyager probes would explore and discover, rewriting the textbooks in the process. A chance interaction with the planets also made such a mission all the more feasible. So what was Voyager's route when it was launched? Okay, so an intern of the Jet Propulsion Laboratory, or JPL, Gary Flandro, realised that the four outermost planets would be aligned during the late 1970s. A chance of 3 lifetimes, he said, so a route for a single probe to complete the grand tour was clear. Using the gravity of one planet to move to the next in a gravity-assisted trajectory. However, this initial plan was seen as too expensive after the planetary exploration funds were slashed. So, the race was on to find a cheaper alternative and yet take advantage of the rare planetary alignment. So, a pair of identical probes were built to replace the earlier plan, and in a competition run by NASA, the new mission was named Voyager. Now, Voyager 1 was set to closely fly by Jupiter and Saturn, while Voyager 2 would pass these planets from slightly further outwards and follow its own trajectory to explore Uranus and Neptune. So they both had their own mission statement, if you like, very similar, twin sisters, but they were going to go separate ways to capture some really interesting data about these planets that we wouldn't necessarily learn. So what is on the Voyager probe? Well, the twin probes each weighed 722 kilograms and is full of scientific instruments, radio systems, and their power sources. Solar energy was not an option given that Voyager 1 would be travelling 778 million kilometres from the Sun, and Voyager 2 needed to be functional as far as 4.5 billion kilometres from the Sun. So solar power was not an option, solar energy wasn't an option. So the best alternative was nuclear power in the form of radioisotope thermoelectric generators, or RTGS, which contained plutonium-238 that would decay to produce heat, which was converted to electricity. Now each probe holds 11 instruments for analysis. These include examining atmospheric chemistry, magnetic fields, detecting aurorae, measuring charged particles, using radio signals to determine physical properties of the planets, and detecting solar wind through plasma measurements. So, on the 20th of August 1977, Voyager 2 launched from Cape Canaveral, Florida, and it was soon followed by Voyager 1 on the 5th of September 1977. But the question from most people's lips is, why was Voyager 1 launched after Voyager 2? Well, this is due to the different trajectories of the two craft, you see. So Voyager 2 needed to travel much further to the two outermost planets. So it was launched first due to the preferable conditions of the planetary systems. So Voyager 1 would be launched second, for it has a much shorter journey. But it would still overtake Voyager 2 before reaching Jupiter. So what did the twins discover? Well, fantastic data actually. So on a 50-month journey, Voyager 1 arrived at the planet Jupiter. It was soon followed by Voyager 2 a few months later. So one of the first surprises was the discovery that its moon appeared to be geologically active. A trait known only to belong to Earth. As a third the size of our planet, Lo's volcanic activity yields twice as much energy, making it the most geologically active place in the solar system. Data from Voyager also discovered that Jupiter's magnetosphere is much larger than previously thought. Extending as far as the orbit of Saturn, infrared measurements indicated the composition of Jupiter to be mostly hydrogen, with some helium and trace amount of water, methane, ammonia and rock. After Voyager 1's closest approach, it captured another astonishing image. It depicted a narrow ring closely surrounding the planet, something which had been thought impossible for Jupiter to sustain. Comprised of dark rocky grains, it prompted speculation that the ring was made of debris from an ancient moon, with similar compositions to the newly discovered moons, which was Thebe, Metis and Adrastea. The heavily created moon Ganymede, the largest satellite in the solar system, was found to have a very thin atmosphere. And then with Saturn, a lot of discoveries made by the Voyager team on the approach to Saturn started with the flyby of its moon, Titan. Known to have a thick atmosphere, it was uncovered to be much more of a substantial than predicted when Voyager 1 drifted beneath the orange clouds. So until then, Titan was thought to be the largest moon in the solar system. But the diameter of the solid center was found through radio signals to be smaller than Jupiter's Ganymede. Titan also had an axial tilt, and Voyager 1 was able to witness distinct seasons as the gases migrated from each hemisphere. Voyager was also tasked with photographing Saturn's intricate ring system, which revealed very thin bands, spokes and gaps produced by shepherd moons Prometheus and Pandora. Further discoveries into the moon's influence of the ring structure unveiled a new moon, and this was Pan, which was a tiny speck in an image captured by Voyager 2. This flyby of Saturn marked the end of Voyager's planetary expedition. Then looking at Uranus, after Voyager 2's 5-year hibernation, it finally reached Uranus. So this was 1986, and it discovered a mysterious new world. So the probe captured images of an aquamarine coloured planet and recorded a uniform temperature of minus 216 degrees centigrade across Uranus's atmosphere, and the magnetometer data measured the day to be only 17.25 hours. Voyager 2 also observed polar aurorae in different positions to the planet's rotational poles. Uranus's aurorae produce powerful high-energy radiation, stripping any atmosphere from its moons, shown by Voyager 2's imaging of the dark, dusty, natural satellites. Ten new moons were also discovered, and only 2 moons were found to shepherd Uranus's rings Ophelia and Cordelia. Voyager 2 reached its final planetary destination, and that was Neptune. So the sky blue coloured planet, composed of primarily hydrogen and helium, but with notable abundances of ammonia, methane and hydrogen cyanide. The probe measures Neptune's day to be 16.1 hours and discovered 6 new moons and revealed an eagerly awaited ring system. The outermost ring had an inconsistent width, leading scientists to conclude that the debris was from ancient moons, and smaller moons, Thalassa and Nereid, would later contribute to the moon system. So, the question remains, what happened after the Voyager probes completed their missions? Well, Voyager 1 completed its mission after passing Saturn, and it continued its trajectory into the outer solar system. And it overtook Pioneer 10 to be the furthest human-made object away from the Sun in 1998. In 1990, the probe captured an iconic image of Earth, which was a pale blue dot as it looked back towards our solar system. The journey then fell quiet for Voyager 1, and until 2002, when it started to detect energetic particles, inferring that it reached a boundary of the solar system, known as the termination shock. This boundary is the point of where the solar wind abruptly slows down as it encounters interstellar winds, resulting in the particles bunching up enough for the increase to be detected. The Voyager interstellar mission team took almost 2 years to confirm Voyager 1's position, as the plasma detector best suited for measuring solar winds had previously stopped working during the Saturn flyby. So Voyager 2 crossed this region 3 years later at a different point, so was able to confirm that our solar system was not round, but it is in fact squashed. So by 2012, Voyager 1 had travelled to the outermost boundary between our system and interstellar space, heliopause, which is where the solar winds are forced back around the heliosphere by the interstellar winds from the Milky Way and nearby supernovae. The iconic Voyager 1 is now humanity's first interstellar traveller, collecting further information on the importance of the heliosphere, which protects our solar system from 75% of galactic cosmic rays, which have the ability to wreak havoc with our precious ozone layer and of course destroy DNA. But another question kind of arises, and that is, how long will Voyager last in interstellar space? And the answer to that question, so from 2020, all instruments aboard each of the Voyagers have been switched off one by one to conserve the remaining power that it has, which is supplied via the decaying RTGs, which I mentioned earlier. The final instruments will be shut down in 2025, which is next year, when only a periodic faint electronic blip will be received, and that is it. Now this will indicate the pair's position beyond the solar system for the following few years. So, what can Voyager tell us about interstellar space? Well, initially presumed to be a vast empty expanse, analysis of the interstellar medium would help scientists understand dark matter, from the birth of stars to the origins of life. Dark matter, which is an elusive material which holds the Milky Way together and binds it together, could be studied by the Voyager probes in the interstellar medium. So just to think that these two objects are now going completely different directions in this vast, inky blackness is mind-blowing, isn't it? Absolutely mind-blowing. The current proposal, however, is that dark matter is formed of weakly interacting massive particles which cannot be analysed by the 40-year-old instruments on the probes. However, in theory, they could detect the particles produced when two weakly interacting massive particles collide in a process known as annihilation. So, let's talk about the golden record that's on board as well. It's a very, very famous golden record. And as the Voyager twins continue on their travels through interstellar space, they're tasked with one final mission, and that is to greet extraterrestrial civilizations. So, long after Earth has lost contact with these Voyager probes as they continue on their mission, the golden records attached to the outside of each craft have the potential to contact our world with another intelligent life form which may exist somewhere else. So, in 1977, a time capsule in the form of a 12-inch golden disc was commissioned to adorn each of the Voyagers, containing a wealth of information to depict Earth and humanity, as well as inscriptions in the gold-plated copper disc. On how to read it, there are also ultra-pure samples of uranium-238 to determine the age of the probe once it reaches life, along beside a map to locate our Sun, and with reference to the 4 known pulsars. The contents of the golden record, including 116 analog and coded images, a greeting in 55 different Earth languages, 12 minutes of natural sounds from the Earth, and 90 minutes of music. Now, these were chosen by Carl Sagan and SETI's Frank Drake after collaborating with historians and artists and folklorists and lots of other people to give the best impression of our planet Earth. So as of 2023, the Voyagers are still in operation and beyond the outer boundary of the helisphere in interstellar space. They collect and transmit useful data back here still to this day. And Voyager did things nobody predicted. It found scenes that nobody expected and promises to outlive its inventors. And I'm just looking on Google right now to see where it is. Now, looking at this, Voyager 1 is furthest away. Well, that concludes this fascinating discussion about the Voyager probes. Of course, I've just been reading articles from online, but I do hope you found this fascinating, and who knows, of one day they will continue to reach out and travel out into the cosmos, and who knows, it might be picked up by an alien civilization who will tell them all about us. I do hope you have enjoyed this chat, and please leave me some comments down below what you think of the Voyager missions. It'd be great to get your feedback. But until then, I'm going to wish you a good night and sleep tight, and I will see you all very soon.